So you can see screen one, my
Yeah, we
Otis,
can see
like
it.
the
Yeah.
VMware.
Yeah.
So I this time I use the MATLAB from VMware as well to just do a little bit demonstration on how we actually use VMware. If you have already downloaded the MATLAB locally, like here, you can also use that. So if you're using VMware, double click that and you jump to this workspace.uts.edu.au, double click it. Username usually is just your student ID, password, and login. And over here, you have MATLAB. So in the VMware one, the MATLAB is 2019 beta. So I think it should be good enough for all the commands. If you download any MATLAB, like the older version, anything older than the 2018 one, I would recommend you to upgrade to newer ones. So as long as it's newer than R 2018, it should be all right. So this is one example of the new CWT. I'll probably go here. Let's open this one. Let's try to open. Sometimes it runs a bit slowly. But yeah, we got this one. So this is the example of the CWT I want to show you guys. It's not exactly a biomedical signal. It's a sine signal with two amplitude. One is so the first amplitude is 1, so that means it doesn't increase on the y-axis, but the second one when the amplitude becomes 2. And another thing you need to focus is in the sine wave, you have frequency 1 and frequency 2, which is 32 and 64. That means you have 32 hertz in the first sine and 64 hertz in the second sine function. The first sine function valid from time from 0.1 to 0.3. The second sine function valid from 0.6 to 0.9. And if we plot this thing, and if we write to pass, yeah, so you can see it generates several figures. Let's look at the first figure first. So this is the first figure. As we predicted, the first part is from 0.1 to 0.3 sine function, and the second one time from 0.6 to 0.9, another sine function. But the first one, you have different amplitude, different frequency, as we predicted just now from these equations. Then if we apply the filter CWT filter bank, this function here, that is we can generate this figure, which is a CWT filter bank. And to use this filter bank as the input, we simply put CWT as a function here. Then we will have this figure. So in this figure, we have 3 information. On the left hand of the y-axis is the frequency. Here is the time, and here is the magnitude in frequency domain. So in MATLAB, I think you have already know that there's like a data type thing. When you click it and you click it to where you want it, it will show you the exact number, the exact statistics. So say from zero point 0.6 to 0.9, we expect to have a frequency relatively around this number 64, right? And in this case, we do have something around there. So 65, 64, we have the brightest yellow. That means we have the highest magnitude around this area. And when we go to from 0.1 to 0.3, we have frequency around 32, 33, that around in this area. That's actually is exactly what we expected from this equation here. So this example is already, I got this example from Matlab official website. So, and I post those links already on Canvas. So if you go to Canvas modules, week 5. So in this page, the first task, I think the first 2 tasks are the things that we did last week. If you didn't come last week, you can start from step 1. The first part is just introducing what we need for stage 2, some data bases here. You can download your data from either one of them, so you don't need to do all of them. Just read the description and decide which one is the most interesting one, and start to download the data and try Fourier transform, fast Fourier transform and short-term Fourier transform, as we explained before. And in this week, we want you to try the continuous wavelet transform and discrete wavelet transform in both Matlab and LabVIEW on those signals that you got from the databases. So yeah, that's pretty much what we need to do in today's lab or this week's lab. Any questions?
Yeah, Gary, you did a good explanation, but is for the reading data, is that some particular thing you want to say? Because you put the data from PhysioNet, is that
Yeah.
the data type for use MATLAB to read is similar with Simon 1?
Yes, yes. If you just for one example, we can go through the database one. So the first file that I put up is one description of what this database is about. You can give a quick read here, see whether you're interested in this. And for more information, it's a first link over here. So if you click it, it directs to you this PhysioNet website. And once you have read, okay, this is what you want to do, you move your cursor here, PhysioNet. You don't really need to click, just move it there, and you move to PhysioBank, PhysioBank ATM, and just click the ATM thing. And it directs to the exact database that you just looked, and you select the right record, the right signal. In this case, it can be all the signals or just the angle or just ECG. And here, text box, this is where you want, how you want the data is read. It can show as text files. It can show as CSV. I think CSV should be the easiest one for both Matlab and LabVIEW. So I would recommend export signal as CSV. If you click that, you probably need to go through the database description before you select any one of these. Some of the signal collected every 8 seconds. Some of the signal lasts more than 1 hour. So you have to be careful when you choose the length, the time format. I think that usually just seconds. And data format, that can be just ROIDC or standard. Sometimes there's a difference, like when they put the database out, they did some the standard feature extraction or signal processing already. So the raw signal is a good start as well, or I think standard should be okay as well.
Maybe select raw signal. Sometimes if process signal is sometimes it's difficult to continue to do work.
Yep. Okay. Then if you want to just download the signal, it's right here, samples, CSV. Left click it, you will download right here. And when you open it, you just open it here. So you have the first column in time, second column, since we select all signal, it's blood pressure in millimeter mercury, ECG micro volt, and also in degrees. So yeah, that's pretty much how you download the data. Any questions?
Yeah, that's great. Yeah. Any questions? Maybe
Right.
next week we introduce the DWT in the live view later, but now I think it's enough. Maybe I mean, if you have no questions, ask for Jeffy and Kari. Maybe we have a rest for 10 minutes, and Kari maybe separate the room.
Yep.
Yeah, Kari, are you currently the host, right?
Yes, I am.
Yeah, maybe you uh break out the room,
Yeah.
and then we waiting for 10 minutes and join you.
Yeah.
Okay, thank you so much.
No problem.
Thank you.